After you log in, your browser and your app both need to prove it's still you on every single request that follows. Where does that proof actually live? There are two very different answers. One lives in your browser, and you never write a line of code to send it. The other lives in your app, and you have to attach it yourself every time. Get this difference right, and two of the internet's most common security bugs finally make sense: cross-site request forgery and cross-site scripting. Get it wrong, and you're vulnerable to one of them without even knowing it.
Let's start with where the proof of who you are actually sits. With a cookie, the server hands it to your browser once, right after login, and the browser tucks it away in its own storage. Think of it like a jar the browser keeps for that one website. With a token, the server hands it back the exact same way, but nobody automatically stores it anywhere. Your app's own code has to save it, usually in a spot called local storage, or just in memory. Same job, two completely different homes for the answer.
Here's the cookie side, in code. On login, the server creates a session and sends back one header, setCookie, with a name and a value. That's it. From that point on, every request your browser makes to this same website automatically includes a header saying, "Here's that cookie." You never call a function named sendTheCookie. The browser does it for you, silently, on every request forever, or until the cookie expires.
And that auto-attach is the whole point of a cookie. Load your profile page, check your orders, submit a form. 3 completely different requests, and the browser stamps the same cookie onto every one of them without being asked. That's fantastic ergonomics. You genuinely don't have to think about it. But notice what that also means. The browser will attach that cookie to a request no matter which page told it to make that request. It doesn't check who's asking.
And that's exactly the trap. It has a name: cross-site request forgery, or CSRF for short. A fake request, forged from a different site, that rides along on your real login. The browser doesn't check where a request came from before deciding whether to attach your cookie. It only checks which website the request is going to. So a completely different website, one you're simply visiting and not logging into, can quietly trigger a request to your bank, and your browser will happily attach your real session cookie to it.
Here's what that actually looks like. Some other site, call it attacker.example, has a plain HTML form on it, pointed at bank.example/transfer, with the money already filled in. Add one script tag that submits the form the instant the page loads, and you never had to click anything. No password is stolen, no cookie is read. The attacker doesn't need your cookie's value at all. They just needed your browser to attach it for them.
The fix is 2 small things working together. First, mark the cookie SameSite Strict, so the browser refuses to attach it on a request that started from another site in the first place. Second, add a separate CSRF token, a random value the server also expects on that request, and reject anything that's missing it. SameSite closes the door for most browsers today. The token catches what slips through.
Now the token side. Login still returns a signed piece of text. Think of it as a tamper-proof note the server can check later. But storing it and sending it are entirely on you. You save it, often in local storage. Then, on every later request, you manually add a header yourself: Authorization Bearer and the token. If you forget that line, the request simply goes out with no proof of who you are.
That manual step is annoying to write, and it's also the whole reason tokens exist. Because you're the one attaching it, it doesn't matter what website or app is making the request. A native mobile app can attach it. A request to a completely different company's API can attach it. Nothing here is tied to one browser's cookie jar for one domain. The cost of typing that header yourself buys you the freedom to use it anywhere. But manual cuts both ways. If your own JavaScript can read that token out of storage to attach it, then any JavaScript running on your page can read it too. That's the other classic bug: cross-site scripting, or XSS, a way of getting malicious code to run inside your own page. It doesn't need to trick your browser like CSRF does. It just needs one gap, an unescaped comment, an unvetted script from somewhere, and it's already got the run of the page.
Here's how small that theft can be. One injected script tag, 3 lines. Read the token out of local storage and send it to an attacker's own server. No password prompt, no browser warning, nothing forged. Just your own storage, read by code that shouldn't be there. And here's the part that stings.
A cookie marked HTTP only would have been completely invisible to this exact line. A token in local storage has no such shield.
And that's the mirror, the one thing worth memorizing out of all of this. Mark a cookie HTTP only, and JavaScript flat out cannot read its value. Safe from theft by injected script, but it still auto-attaches, so it's exposed to a forged cross-site request. Put a token in local storage instead, and it's the exact opposite. Nothing forges it, because nothing attaches it for you, but any script on your page can read it straight out. Each one is safe from exactly one attack, and exposed to exactly the other.
Put a number on it. Forging a cookie-based request takes 0 lines of attacker JavaScript, just a form and an auto-submit. Stealing a local storage token takes about 1 line. Read it, send it. That's how cheap both attacks are, which is why most real systems don't pick a side. They run an HTTP-only cookie for the browser session and hand out a separate bearer token for mobile apps and external APIs. 2 credentials, 1 pattern. If that made the mirror click, hit like and subscribe. I take one concept all the way down to the code, every time. There's a 100-second version of this in the description if you just want the summary. Next time, why an HTTP-only cookie and a SameSite flag still aren't the whole story once you add a third-party login button.